Another great new feature of version 8 of Particleworks is the ability to define your domain using a geometry file rather than a box. One example of where this is a useful application is for this V-engine piston cooling simulation. Now in this case, I'm only looking to simulate a single pistoned spray cooling, but because I'm not able to rotate the domain to be in line with the piston, we have a buildup of particles on the housing that we do not need to consider. This is clearly going to increase our simulation time and overall mean that we cannot run as fast as if we could only consider the particles within the liner and from the spray. So go and take a look at this pre-ran version where we have included a file domain. The way this works is we select our domain, go down to Details, and in Type we can change it from Default to File. From there we can pick any STL file and it will be imported into that location. Now, when any particle crosses that domain, it will be removed as normal if it was crossing the box boundary. If we then compare the two simulations, and especially look at the number of particles, which I've plotted onto these graphs, we can see that the numbers of particles in the box domain is increasing steadily, and by the end of the 0.25 seconds, we have almost 70,000 particles. In the file domain case, however, the number of particles stabilizes very quickly, with a maximum of just over 50,000 particles. So significantly less particles, even over these short time periods, and over longer simulations will save huge amounts of simulation time by not simulating particles that we are not interested in. Another example of where this would be useful is where we're looking at the internal airflow within an engine, e-motor, or transmission. In these applications, when we're using the FVM solver, we have areas outside of the housing that will be included in the domain but are not affected by the motion of the components inside the casing. This is a waste of computational time as we are still solving for the airflow on all of these nodes despite there's no boundary conditions in that region. What we can do instead for these applications is actually use the housing as the domain to make sure that only free space inside of the casing is calculated as FVM cells and everything outside is not wasting any computational time.